So welcome to our class. We will be discussing what is called analysis of variance, Anova. Now, Anova is like hypothesis testing, except that we are looking at more than two means. That's why it's called analysis of variance. So analysis of variance was discovered by a farmer who wanted to analyze the difference that was occurring from treatments which were coming from columns. After applying the same fertilizer in the same rows, he was baffled as to how the cobs were different. Applying the same fertilizer, same amount of water, except that some of the cobs were different. They are significantly big, and so he called it Anova. So analysis of variance is also the same criteria, similar to what God will use. Everyone given same opportunities, same privileges. How is it that this one was more faithful than the other? So analysis of variance is a very important concept that even marketers or management uses to promote individuals who are given the same incentives, same vehicles. How come this particular individual is able to score more sales than the other? So the procedure of comparing two populations, we use a Z. But where we are looking at three or more populations, we're using what we call analysis of variance, Anova. Now, a few definitions that would interest you and principles or assumptions, besides the fact that Anova is for 3 and above groups. We also need to know that Anova is also used to compare the variances between these groups within the groups. And there are two types of Anova that we're going to look at. There's Anova between the groups and within the groups. So under Anova, we're going to test a null hypothesis, which is always that the means in the group are equal. In Anova, we actually use what we call the F statistic or F table, which is simply the ratio between the group variance to the ratio within the group variances. So there's a special table that we're going to use. I'll teach you how to look at it. So usually we make a conclusion to say if the F statistic is significant, it indicates that there is a significant difference between the means in the groups. So I'll take you through an Anova table depending on the number of factors involved. So there's a one-way Anova and there's a two-way Anova. One-way Anova only has one factor to consider, a difference between the treatments. Then we also have a two-way Anova that is used. A two-way Anova is used when we're discussing the differences between the blocks and the treatments. So I'll firstly take you through the schedule of the table itself, how to come up with the Anova table. So the Anova table please mute your mics. So Anova table has a format that you need to follow. So there's one-way Anova and two-way Anova. So this is the table that we consider. So you need to master this table very well. Sometimes what you need is only to master the balancing. Okay. Well, let me just zoom it for you. So, okay. We have what we call the variations between, which is sum of square between, and the variations within the samples, sum of square W within, and sum of square total is here. Then we have the degree of freedom, which is K minus 1. K is the number of treatments.
Collins, I can't see the table from my end.
Can the others see the table?
It must be
Yes,
the internet.
yes, we can see it.
Can you see it now?
No, not yet. The screen is just black.
Okay.
You may need,
How about
you may
now?
need to internet.
Maybe I draw it. Can you see it now? Can you see what I'm writing?
Can see
No.
what you're writing.
You can't see
Maybe
what I'm
it's
writing?
just
See.
Doctor, you
I
don't see
can't
what
see
you're writing,
anything.
so I think it's gonna end. It's gonna end. The problem is gonna end.
see, maybe you can refresh.
Yeah, refresh.
Try to refresh or log out and log in. So we have what we call the treatment, we have what we call the error, and we have what we call the total. So we're looking at a one-way ANOVA. All right. We're looking at a one-way ANOVA. So I said, when we're dealing with a one-way ANOVA, we only have variations coming from one angle. For instance, A, B, C. Okay, and then we have 2, 3, 4, 1. Here we have 1, 1, 2, 3. Here we have 2. These are just arbitrary figures I'm putting in there. So K is the number of treatments. Treatments are columns there. So what is our K there? 3.
3.
N is the total number of elements we have. What is our N? 12. Okay, this is a one-way ANOVA because we have variations coming from one factor. It's a one-way ANOVA. We have one title. We can have a two-way ANOVA, for instance, A, B, C, D. This is X, W, and Y. And here we have a number here, a number here, a number there, a number there, a number here, a number. I don't care what number it is. I just want you to get the concept. So this is a what? A two-way ANOVA because we have a title coming from on top. So we have two factors there. So this is a two-way ANOVA. So what is our K?
4.
4. And what is our N? N is the number of rows. 3. And what is the capital N, the total number of elements in here? 3 times 4 is 12, correct. So this is a two-way ANOVA. All right. Now, we have what we call the sum of squares. So now, the source comes from 3 sources. Okay, we have the treatments, which are the columns. We call them what? Between. The same, between. We have the rows, not the rows. That's for a two-way ANOVA. So we have the treatment that is coming within the column. This is error. Then here we have the total. So the sum of squares here, we say sum of square between. Here we say sum of square within. Just the acronyms of the first letter, then sum of square total. TO. Then we have what is called the degree of freedom, DF. This is K minus 1. This is N minus K. This is N minus 1. All right. Then we also have what we call the mean of squares. So we have the mean of square between. We have the mean of square within. So this is just mean of square B, mean of square W. And finally, we have the F calculated from the table. The F calculated is simply when we divide the mean of square between over the mean of square within. All right. So now, like I said, if you are given A, B, and C, here we have a number 1, 2, 3, 4. Okay. Maybe here we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And we are told the sum of square treatment, they've already calculated for you, maybe is 20. And the sum of square total, they've already calculated for you, maybe It's 56. So let's learn how to balance this one here. So can somebody tell me what is our K? What is our K from the data that we have there? What is our K?
3.
Our K is
Okay, it's 3.
And what is our N?
11.
4.
Our N is what?
4.
12. Are we agreeing? Are we together so far?
Yes.
Okay. So if we're together, we can proceed. Together, we can proceed. So here we have already established our what? Our K is 3 and our capital N is what? 12. So let's balance this up. Let me use a different ink. So what do we put here? Sum of square between is the same as sum of square what? Treatment, which is 20, right? Sum of square total has already been given. It's the same, which is 56. So here we're going to put what? 20. And here we're going to put what? 56. All right. Then the difference here. What are we getting? What are we getting? 36. Are we all agreeing? The difference, are we all agreeing?
Yes.
Sorry, are we getting what?
Where is the 36
Which
coming
one
from?
is that?
We are subtracting
Difference
between the
between-
sum of
Okay. We are subtracting the differences there. It's just a normal balancing off, isn't it? So 36. So you see where the 36 is coming from. It's an interesting topic. You will really enjoy this. All right. Can I proceed? So we put the 36. I hope there's no one behind there. So we put 36 here. Or can I rub so that, or it's okay, yes, you're following? So sum of square within is the 36. So we'll put 36 there. Then what do we put our degree of freedom here? K minus 1, 2.
2,
N minus K,
10,
9.
9.
9.
You add these two, or N minus 1. What is N minus 1? 11. Then MSB, when you divide the SS, then divided by the degree of freedom, just divide these two here. 2 into 20, 10.
10,
9 into 36, 4. Then to get the F calculated, we divide 4 into 10, 2.5. So you get 15 marks just for this.
Oh, Collins, I get it now. So the K minus 1, we're just subtracting. Our K was 3, so we just subtract 1, which will give us 2. Then the N minus K. So we subtract the 12 from, we subtract 3 from 12, which will give us 9,
Yes,
right?
yes.
Okay.
Yes.
No. I was wondering why is the 2 and why is the 9, but I've gotten the concept. Okay, thank you.
You've gotten the concept. So you can do it in two ways. You can just add them or N minus 1. It will still give you the same answer. All right. So we're doing it in two ways. So our degree of freedom for the total, we can add those two up. And also, yeah. So is there anyone behind before I proceed?
What does MS stand for?
MS, mean of squares. Mean of squares.
Just to confirm, Mr. Collins, this
Mhm.
is a one-way.
Yes, the one
Just
way
to
and
confirm. Okay. All right. Thank you.
Collins,
So how
how
did
did you
you
get
tell
the
that
10
it's a
and the
one-way?
2?
How do we know it's one way?
Yes.
Yes, there are no blocks there. There are no blocks. I told you how to identify. It was given in the table there. All right. Let's try another one. Okay, you get to understand it more. Okay, suppose we're given A, B, C. So here we have 2, 3, 4, 5. We have 2, 2, 3. We have 1, 4. Okay. So we're also told that our sum of square between is 40. Our sum of square within is 36. So let's come up with our, so in our source, can you help me? What do we have our under source? Between, then we have within, then we have
Total.
total. All right, then here we have what? Sum of squares. Then here we have degree of freedom. And here we have the mean of squares. And here we have the F calculated. So what is our sum of squares? First of all, from here, let's identify what is our K. It's been transposed. So it is coming from this side. So what is our
Is 3.
K is 3, correct? If our K is 3, what is our N?
9.
Our N is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So here, sum of square between we're given what we have?
40.
40.
36.
Then sum of square within
36. 36.
36. Then the total
4.
76.
76. Okay. So then here, what is the degree of freedom?
Oh,
Pardon?
2.
2.
2.
Then here
6.
6. How did you get the 6? Then here,
N minus K. 9.
so here what do we get?
You get 9.
7. Mommy.
Oh. 8.
8.
8. Oh, N minus 1. 8. Are we together so far? Anyone lost?
I want to ask
Lost
about
on the 2 and the 2.
on the K. Why did we get 3 and not 4?
Why did we get what?
3 for K. Why did we get the columns as 3 columns and not?
Not columns, titles here. Here
Oh.
it's like ABC. Here there's no title. All right? The source
Okay, so the K is
here.
where the titles are.
Yes, it has been transposed. So don't
Okay.
count here. And these are not even even. So sometimes it will
Okay.
come up like this from this angle. You can put
All
like
right.
and transpose it. Any other questions?
Mr. Collins, there was a point whereby this other example, you had asked us to calculate the small n. Why is it that we are not calculating the small n, this one and the previous example?
Why are we not calculating the small n? No, that is a two-way ANOVA. I'll get to that.
Okay, all right, thank you.
I'm a bit lost on the 2 and the 6.
bit lost on the 2 and the 6. Can somebody explain?
The 2 is the degrees of freedom, which we find by k minus 1. So in this case, our k was 3 minus 1, we got 2. And then the degree of freedom for the sum of squares within is n minus k. Our n was 9, our k is 3. So 9 minus 3 will give us 6. Then we add those two to get the total of 8.
All right, thank you.
Then here, can somebody continue? Just dividing this guy in there, 20. This guy in there, 6. Here we don't need to do total, the last two columns. And this guy in here, 3.33. Chap. Surely. Na probability and
According.
you will laugh when I show you how he brings the question. That's why he says this man.
The 3.33. He said in where and where?
Can somebody explain that one for me?
We have divided. You can proceed. This one.
No,
Please have confidence, neighbor. Part. Explain.
we said we divided the mean of squares. So we divide the mean of squares between, divide by the mean of squares within, which is 20 divided by 6, which is going to give us 3.33.
So how did we get this? These ones were given. Sometimes instead of being given, you'll be given that one. It's a difference. Okay. How do we get this one? K minus 1. 3 minus 1. How do we get this? N minus k, which is 9 minus 3, which is 6. How do we get this one? Just total it up. How do we get this guy? This guy in there, 20. How do we get the 6? 6 into the 6. That's the answer. Then number last fight. How do we get this figure? This guy in there. All right. Now let's go to one question he brought in the exam from our Bible. Kindly fill up the missing figures. I'll give you 5 minutes. Okay, by now, I expect all of it to be done. So let's go through it. So how do you get the first part here?
I got the first part by subtracting the 72.7 from the 56.68.
Which is what?
Which gave me 15.43.
15 point?
43.
4.3.
4.6.
4.3.
4.3.
43. Then I also did the same for the other part, which I got to 20. I just subtracted the 4 from the 24.
Okay.
Gave me 20. Then I divided the 15.43 from 4 into 15.43, which gave me 3.8 something. When you round it off, to give you 4.
Yes, in fact, your answer is more accurate than I don't know why they put this. It's very confusing. Well, yeah, they're rounded up, correct. And here,
And even the other one, I got 2.8 something. When I rounded it up, it gave me a 3.
2.8, what? Then?
2.8. Then I added this. I got a 7.
You don't need to add here, I said. It's not important. Then how do we get here, the F? How do we get the F?
It's 1.42.
1.42. How did you get the 1.42?
We divided the 4 over 2.8.
All right, that's correct. So let's see what they got. So When you got the difference 15.43, is that what you got? Yes.
Yes.
Then you also want to find our divided by 4. The actual answer was 3.86. They just rounded up.
3.86.
Then you divided 20 in there, which is 2.8 3. Then you divide this into 3.86, which should be 1.36.
Yeah, it gave us 1.4 because we rounded off to 4.
This answer was not actually correct. Yes, 1 point. All right. So you see, it's easier.
Yes, it is.
Yes, it is.
Yeah. Okay. So, unless you have any questions, please ask now. Or forever hold your
I
peace.
noted the rounding of errors. Well, how do you propose we round off?
2 decimal
Because
places.
there were 3 different answers.
There's an acceptable range, okay? So, to the marking key exam, if so if you decide to forget, memorize with terrible exactness. Inga isa which way at 15.43. If
Mr. Collins, I can hear what you're saying.
Oh, okay, sorry. I'm saying for those of you who are lazy at calculating, some of these are coming as exact as they are. So please memorize with terrible exactness the figures as they are. Because we're making a marking key. We'll take you to another one that I need you to balance up. This man has been spoon feeding you so much, so I don't know how I can teach this topic because it's I wanted to teach it the tougher way, but he's oversimplified it. All right, so try to balance up this one as well. So if that one doesn't come, this one will come. Please participate. All right, so we are back. We want to balance up this. So what do we put within here?
4.67.81.
4.81. Here.
4.67.
What is the answer
Not
here?
4.67, it's 467.81.
Oh, 46781, yeah.
467.81. 467.81.
Here.
On top is 3.
3.
3 here.
139.75.
139.75.
Here.
24.62.
Hold on. On 139. How are you getting it? I'm getting a different figure.
We just divided
Oh,
the
419 into 3. 419.25.
3 into 419.
Okay.
Then here.
Thank you.
5.66. I rounded up.
So let's verify your answers. So 3, which one is this one now? That's a 3 you got, the freedom there. Then A is 4, okay. 3. Then sum of square block 467.81. 467.81, correct. Then what else? 139.75. What did you get? 29.75, correct. And what else did you find? 24.62. 24.62. Let's see what you found. Exactly 24.62. And 5.67. 5.68. So this correct, this correct, this correct. All right. So you understood this.
Yeah, actually, I rounded up. That's what I was saying. I wanted to ask, is it a problem to round it up? So it's fine. I think I've been answered. Because I rounded up to 5.68.
Okay. So then we go to, then they ask you how many observations are there. Okay, some of the fun questions, how many observations are there? And how many how does it bring the questions? Let me go to the November paper. Here's the November paper. November paper. Okay, here, let's see whether this. Okay.
Colin, sorry to take you back. How did we find the 5.68?
Okay, how did you find the 5.68?
It's divided 24.6, 2139.75.
Sorry, I didn't hear.
2462 into 139.75 on MS is 2.
All right, thank you.
All right, thank you so much for your time and attention. So we end here. I'll send you some class exercise to do. So what is the total number of observations? Yes. So what are they looking for? What is the total number of observations? So it is this plus 1. It's n. They're looking for n. What was our n for us to reach 22? The total number of observations is what? 23. Right? The other question they'll ask you, how many populations? What's the number of populations? They're asking for k. So how many populations are there? 4. That's k minus 1. 4. So the populations are 4. So that's where the tricky part is. I repeat. Question would be, how many observations are there? They're looking for n. N is the number of observations. So n minus 1 is 22. So what is n? N is 23. 2 marks for that. So if you don't understand the concept, you don't get that. Then how many populations are there? It is k. So if our k minus 1 is 3, so what is our k? K is 4. 2 marks for that. So don't lose marks for that. I've clarified. All right. Okay.
Yeah, just adding,
On
just adding
population, you
one
also
on both.
Yes, population is n. This is not the population here. This is n minus 1. So population, sorry, is k. This is not k, it's k minus 1. Observations is n. I told you observations are the total number of elements. So this is n minus 1. So our observations are how many? They are 23. Our populations are how many? They are 4. There are 4 columns. There's A, B, C, D. These are populations. So k minus 1, that's how it became 3. Is that clear? All right, so our next meeting will be at 20:30. I'll look at hypothesis testing, estimation, and the song. Then I'm done with the syllabus.